Okay, so those are using transformations, finding the different parts of the graph. Now they may give you some weird functions like this example here. And their suggestion is that you use the definition of the absolute value to decide what the graph might look like. Now, I've been through that with students before, and I've found that it tends to confuse them. So what I want you to think about is looking at this function, where is something significant going to happen? And significant things will happen when whatever is inside this absolute value is equal to 0, which is what the definition up here tells us. Whenever you have absolute value of something, it's going to be the negative of that if it's less than 0, and the positive if it's greater than 0. Not that x is 0, but the whole quantity inside the absolute value is equal to 0. So I'm going to use this. Again, you can read in your book if you want to see how they decide exactly what's happening. But here's my suggestion. Take whatever is inside the absolute value and set it equal to 0 and solve it. Okay, don't set up both cases. Just find out what number would make that inside of there equal 0, and we find that it's 3. Okay, so we know that something significant is going to happen in this graph at when x is 3. Another way that you can always graph functions is by choosing values for x, plugging them in to find the corresponding y value, and that's what we're going to do here. I want to make sure that I include 3 in that because I know something different may happen there. And I want to include numbers that are around 3, such as 2 and 4. Okay. I'm going to put in a few more maybe to make sure of what my graph might look like. If x is equal to 3, what happens? If I plug 3 in, I get 3 minus 3 on the top and 3 minus 3 on the bottom. Now that's a problem because that gives me 0 over 0. We cannot have 0 in the bottom of the fraction, so that tells me that this is what's called undefined, and it won't even have a point on the graph. Okay? That also tells me that for my domain, it's going to be all real numbers except for 0, or excuse me, except for 3. Okay? Let's continue trying to graph. Let's put 2 in there and see what happens. If we put 2 in for x, I get the absolute value of negative 1 over negative 1. The absolute value of negative 1 is 1 over negative 1 would be negative 1. So I know the point 2, negative 1 is on my graph. Okay? Let's try 4. Do 4 in blue here. If I put 4 into my function, I get the absolute value of 4 minus 3 over 4 minus 3, which gives me the absolute value of 1 over 1. 1 over 1 is 1. So I know the point 4, 1 is on my graph also. Okay? Now, let's see what happens a little further. Okay? Let's see what happens at 1, and let's see what happens at 5. Again, we just want things that are close to these numbers. So let's try 1. The absolute value of 1 minus 3 over 1 minus 3 is going to give me the absolute value of negative 2 over negative 2, which gives me 2 divided by negative 2, or negative 1. So I have the point 1, negative 1. Okay? 5, let's plug 5 into our function. We're all over the place here. 5 minus 3, absolute value over 5 minus 3 gives me absolute value of 2 over 2, or 1. So I have the point 5, 1 on my graph. So notice the bottom seems to be all at negative 1. The top up here seems to be all at 1. We know that 3 is undefined, so we're going to put an open circle there and there. And then we want to connect the dots here. You can plug in more values if you want to test the function. That's just fine. Okay, what they would tell you to do in the book. This is what our graph looks like, oddly enough. Notice our domain here would be everything except for 3 because of those open holes there, and that's because we can't have a denominator of 0. Our range, our y values are only 1 and -1 and nothing else. Okay, so this one's a little different. Now, when they said to use the definition, what they were wanting us to do is to say that f of x would be equal to x minus 3 excuse me, sorry, had an interruption there. Okay, depending on our value, if x minus 3 is less than 0, and if x minus 3, the quantity inside the absolute value, is greater than 0. Okay, so we end up with these two functions. They changed right here at 3. Let's do one more of those. That was a little crazy.